And welcome to another installment of Spring Tips. In today's installment, we're going to look at Project Riff and Spring Cloud Function. Project Riff is a new project from Pivotal. It's an open source project that we started last year, and it provides a function as a service runtime. Functions as a service have become very, very popular of late because they provide an even more concise, even more abbreviated deployment model for functionality. Remember, as with all things, economics informs architecture. And so we see a lot of people looking to get even more agility, and they found some workloads, they managed to describe some certain workloads in terms of very simple message in, message out style semantics. And I think this is actually a really, really interesting sort of coming of full circle. We who have been around long enough will probably remember the term back office, right? The idea that you had work that didn't belong on the hot path of the front end web application, the work that needs to be done that might take a little longer than, for example, the milliseconds that you can afford for a given request response. And typically, historically, traditionally, that work would have been staged in terms of queues. So you would have taken the work, put it on a queue, and then had something process it as appropriate, right? And this is as simple as this idea sounds, this is the fundamental reason that people have to start thinking about architecture instead of just plowing everything into a giant web application. And for a lot of people, this is integration, this is messaging, this is the world that comes out of the need to be able to do things that take a little longer asynchronously. So this whole world, this whole phenomenon of things that I need to do that need to happen eventually, but not necessarily this second, is still there very much, and we've certainly got some very nice primitives for solving problems in this way. Obviously, in earlier installments of Spring Tips, we've looked at Spring Integration and Spring Cloud Stream and Spring Cloud Dataflow. Now, going full circle, the cloud providers now have a approach to modeling discrete units of functionality as a single function. And when they say a function, they're not actually talking necessarily about a language-centric concept of a function, but instead this thing that takes a parameter and then returns output. So data in, data out. Very, very simple concept. And if you extrapolate, then this is a concept that can scale out to multiple languages and runtimes, not just Java or JavaScript or something like that. And so you'll no doubt be aware of Amazon's Lambda. Amazon's Lambda is AWS Lambda is a runtime for deploying functions in certain languages, not all languages. And the runtime will spin up an instance of your application and forward the parameters, the request payloads that are sent to that function to the function, give your function a chance to run, and then send the response back out. Optionally, it'll forward that response, the output value, to another function, and the result is that you can chain things together. This was, I think, arguably the first very successful, popular function as a service runtime, but is by no means the only one. At this point, all of the big three have options here in this space. Google and Azure all have very competitive offerings, and there are now a number of different open source runtimes as well. So obviously there's OpenWhisk, which is an open source runtime, and there's what's that one? Oracle just released one as well. Oracle's got one as well. So there's a number of different options. We have one called Project Riff. Riff, of course, is for functions, which is to say that Riff is for functions, which is to say that Riff is for function. It's a recursive acronym, my friends. It has to be a recursive acronym, otherwise it wouldn't be cool. So we have a function as a service runtime, and Riff is a polyglot function as a service runtime, just like Cloud Foundry is a polyglot platform as a service. And the goal here is to support the deployment and lifecycle of functions, discrete units of functionality that can be thought of as functions. And it's important to have that distinction. It's not actually necessarily a language level function, right? We can support, for example, a bash script or a shell script, right? And these shell scripts can take parameters and they can produce output, so standard in, standard out. Riff is built on top of Kubernetes. It's deployed, it's implemented in terms of resources for Kubernetes. We introduce a couple of new resources, one of which is a topic, and another of which is a function. And you can manage Riff on top of any Kubernetes instance. Obviously, we have a PKS, our Kubernetes, the pivotal Kubernetes service. That runtime is I think an ideal fit because it works nicely with Cloud Foundry. But again, this will work with anything. So I have Riff and Kubernetes installed on my local machine. The docs here are very thorough. There's a number of different ways to install Riff on Docker for Mac, Docker for Windows, Minikube on your local virtual machine, which is what I'm using on my Linux box here, and of course Google Cloud, Google Container Engine, or Google Kubernetes Engine. That's on Google. All of these are fine choices, and again, anywhere else would work just fine. But the installation is not that complicated. The gist of it is that you have to get your Kubernetes installation up and running somehow. So this is fairly easy with Minikube. You evaluate the Minikube Docker environment, and then finally you use Helm. Helm is a package manager for Kubernetes. So you use Helm. We distribute Project Riff as a Helm chart that you can then use. And once you're done with that, you install Kafka, and you wait for things to spin up, and there you are. You have a fully working runtime. The only thing you'll need then is a CLI, so you can download that CLI. And then you install invokers, and these invokers are the things that actually invoke your functions, right? These are sort of sidecars that run in the container that take messages coming off of queues, in this case Kafka, and then forward them to your functions. Now, if your function isn't running, right, if you haven't run it yet, then this sidecar will make sure that there's an instance available to handle it. And if there is no more traffic, if you send one request and then wait 15 seconds, which is the default timeout, then you will get a you'll see that the function will scale down to 0. You'll have 0 instances of the function running. If, however, there are successive requests that happen in that 15-second interval, then the same image will be reused to serve those multiple successive invocations. And if you have an overwhelming deluge of traffic that can't be effectively handled, that is to say, your availability goes down, then the runtime will scale it up as needed. It'll scale up to 2 instances, 5, 100, whatever is required to be able to satisfy the demand. And then eventually, as I say, it'll scale back down to 0 instances. This is what vendors mean when they say that function as a service runtimes or serverless runtimes scale to 0. The consequence, of course, of scaling to 0 is that you are going to have to pay the cold start tax, right? So the next time there's a request, it's going to boot up that image that has your function, including the sidecar, and then wait for it to spin up, right? Well, this means that if you're running a Python function or a Java function or whatever, then you have to wait for that runtime to start up, right? And that's why I think these are ideally suited sort of for back office things for which a second startup tax is not so problematic, especially since we know the result will come. It's just not going to necessarily come immediately. It'll be staged through queues. You're not going to lose data also because you have those queues. So let's go ahead and take a look at this. Let's go ahead and look at some simple examples here. Now, keep in mind, this is a multi-language runtime, multi-platform runtime, and as you can see from these different invokers here, that there's a support for commands. These are shell scripts, bin sh shell scripts. There's Go, the Go language, Java, which is the one we're going to spend most of our time with here today, Node, as in Node.js, and then of course Python 3. So all of these are supported out of the box, and it wouldn't be hard to add support for more. The runtime itself is written in Go, right? So we have a lot of different options here, a lot of different supported technologies. Okay, so let's go ahead and get started. We're going to go ahead and just get started with a very simple example. I have in the background here kubectl. It's on a watch. It's every 1 second I'm refreshing kubectl or kubectl get pods deployments and getting all the namespaces, right? So there's that. I'm going to actually run something different here. I'll run demo, which will show me a lot more. It'll show me the functions, the topics, the deployments, and the pods. All right. So you can see I've got nothing there. I've also got Riff, the CLI. So let's do eval minikube docker env first, just to make sure that our Docker context is pointing to the right runtime there. And I'll say riff list. And when I do that, I see there's nothing there. Okay. Now I've got nothing in my directory here either, so I'm going to go ahead and let's go ahead and build a very, very simple example. We'll start with a Node.js example, which is a little sacrosanct, I know, but we're going to do it because I want to have a lot of different options here. So we're going to create the example that's you know, a very, very, very straightforward example that'll reverse a string. Okay, so reverse, and we're going to create a reverse.js file, and it'll just be a node module. So module.exports equals string lambda syntax. I always get that confused because it's different from Kotlin and Java, but it's similar to Scala. And then we're going to take the string that comes in and split it. What we're doing is we're creating a lambda here, right? So the input is the string that's going to be sent from the client. And the client, by the way, is going to post to the function as a service gateway, the HTTP gateway. That is how messages arrive into the system. So you don't get control over the URLs. You don't get control over, you know, the addressability of any particular function. It just is what it is. And again, this is another reason why I would use this for back-end kind of stuff, back office kind of work. So I'm going to take the string and split it by empty quote, which would say it's going to turn into an array. It'll take each character. And turn that into an element in a different array, in an array. Then I'm going to reverse the array. Then I'm going to join the whole thing back together like so. Again, fairly trivial example, but it does demonstrate what we're trying to do. Now, we have this file here in a directory called reverse. So we're going to say riff create node. So I'm going to create a node function. And again, keep in mind, we're going to create a function named reverse. And we want this function to be addressable on the input Kafka topic called reverse. So whenever somebody sends a payload into the reverse topic, it'll end up in our function. So we're going to call that input topic reverse. Now we could specify an output topic, right? We'll see that in a minute, but for our purposes, it suffices to leave this as is. So we're going to say create node name reverse input reverse and file path will be equal to this. Okay, so that's going to create a number of different artifacts here. You can see we have the Docker file that describes our function, and we can see that the Docker file really is just a simple Docker file that extends from the node function invoker, adding our little script and providing the function URL. Okay, and the node function invoker will know to look at this function and to invoke it, and then take the output of that and put it on the output Kafka queue, or send it back to as a response if you like. All right, so that's this, and then you can see there's also Kubernetes YAML files, config files for the different resources here. So in particular, you've got reverse topics.yaml. All right, that's just the Kafka topic. Nothing. I don't usually have to mess with that, but it's there if you want it. And reverse function.yaml. This is a little bit more interesting. So you can see here that it's fairly straightforward. We're going to see later on that it's useful sometimes to be able to fiddle with this container segment here, the stanza here. But basically, we're saying this is a function. The inputs are going to be coming in on the gRPC protocol. So the function invoker speaks gRPC to the function, and it gets turned into the payload that we then recognize and can work with. And that's it, right? That's the sum total of all that. That's the whole thing. And now, if you do riff list, you can see we've got a function in there. So let's go ahead and try publishing a result, or a request rather, to it. I could continue spelling out input, but in all these different commands, you can use I and N. So I is input, N is name. Here, I only need, since I'm sending a request, I only need to specify the input Kafka on which the Kafka topic on which I want the request to arrive. So I will say riff publish, and then we call this reverse, right? It's up there in the name there. So reverse, and then we will specify some data. So we'll say hello world, all right? And then we're going to say that we want the response to come back. If we don't specify response, -r, or expecting a reply, if we don't specify, it'll be a fire and forget. So it'll be sent over the Kafka queue, and it'll be delivered when possible, ASAP, right? But I want the response. I want to see the results, so I'll wait for that response to spin up, all right? So there we are. There's our very simple hello world example using Node.js. Now again, a little slow. Obviously, it's a little slow in the first time you send a request. But if we do it enough times, you can see that it's fairly quick, right? The result, this goes to a Kafka queue, hits the function, gets put back on a Kafka queue and gets sent back, and we get it done. It gets sent to through the HTTP gateway and then back, as HTTP, all in that split second. Again, if we wait a few seconds though, if we wait 15 seconds to be precise, then we make the request. You can see that we have to wait for it to spin up here, and you can see that it's doing that here, right? You can see it's spun up, as we wanted it to. Okay, now we've got the reverse function. That's a node. Let's go ahead and create a Java version, obviously. So here we can use Spring Cloud Function. Now, Spring Cloud Function is a new project from the Spring Cloud team. There are, unfortunately, not just yet checkboxes here on the initializer, but I have a suspicion that'll be there in a month or so. So all we need, I think, for our purposes is Lombok, maybe. You could use any language. Again, anything on the JVM will work just fine. Anything that Spring Boot can work with, including Scala, for example, would work just fine. But we're going to just leave it in Java because it's a simple enough example. So we'll hit generate. And what we're going to do is we're going to create a function that takes that reverse string and uppercases it. Or we're going to uppercase a string and then send it to the hello world, or to the reverse function. So now I've got uppercase. And I'm going to add Spring Cloud Function. Now, Spring Cloud Function is as I say, it's a new project. Its purpose is to allow you to write functions and then adapt them to different function as a service runtimes, of which Project Riff is just one. So this is it's a nice technology to have. I have an example on my GitHub. I can link to it in the README for the example for this on spring-tips on GitHub. You'll see the code for this. I have an example that uses Spring Cloud Function, for example, to deploy the gateway, the endpoint and the function itself and all this other stuff that you need for AWS Lambda. So it's tedious to use AWS Lambda because Lambda requires you have all these extra types on the class path in order for it to work. And the goal of Spring Cloud Function is to adapt your function as much as possible from the underlying runtime, or to extricate it from the underlying runtime while allowing it to remain portable. So again, with the use of adapters and the right Maven configuration, you can take this code that we're going to write here right now, and eventually, with a lot more configuration, get it to work on AWS Lambda. And that's not configuration required because of Spring; it's just configuration because of AWS Lambda, which is actually pretty tedious. AWS Lambda has an easy-to-use sort of 5-minute demo use case, which is you log in, you upload a jar, hit deploy, click a checkbox or 2 or 10, and you get a gateway, and you can make a request to the gateway. But if you want to automate that, then it gets particularly burdensome. So I'm not going to waste the next hour trying to get all that done here for us, because I don't care. And then also we have Project Riff, which is much simpler. So all we're going to do is we're going to add Spring Cloud Function, and it'll do the rest. So Spring Cloud Function dependencies. I have this in my local class path. If you don't have it in your local class path, you'll need to add the Maven Snapshot repository for Spring. So it's spring.io. It's out there. So if you go to start.spring.io and choose Snapshot for something, it'll automatically add it for you. But I don't need to. I forgot to do that. It doesn't matter. It'll still work. Type is equal to pom. Okay, so there we are. There's the dependencies that I need. You would need a dependency. You'd need a repository stanza if you've never done this. And then finally, I'm just going to go ahead and add Spring Cloud Function Starter Web. All right, that's the web dependency. That's the web support for Spring Cloud Function. All right, now that's on the class path. Let's go ahead and build a very simple function here. And the whole point of this is to create a very simple function that can uppercase a string. So you say function, literally just function, Java util 8. By the way, this is Java 8 or better function. And we could do this a couple ways. We could say, I want to take a string and then return a string, like so. So you say return input. Input becomes to uppercase. That's output, right? That's certainly one option. You couldn't get simpler. Or, and I think this is more useful in a lot of cases, we could use the Reactive Streams publisher, type. And in particular, we can use the Reactor project, which is the reactive runtime that builds on top of Reactive Streams. We could use the Reactor project to describe the incoming stream of requests as a flux. A flux is a publisher. It's a thing that emits items, just like the Reactive Streams publisher. It implements the Reactive Streams publisher interface, but it is a thing that emits items, and it could be potentially unbounded. So and it has operators that we can use to iterate, traverse, filter, or whatever over the values, just like we would want to do. So here I'm going to say function flux of string is going to produce a flux of string, right? So uppercase return null. Let's get this compiling. Flux. Did I miss a dependency here? Spring Cloud function. Starter function web. Yeah. There we are. All right. So that in this case is a incoming flux. I'm going to say incoming flux dot map. S, that's the string, dot to uppercase. So again, this is a reactive API, right? I can use the reactive web client from Spring Framework 5. This is all stuff that was introduced in, I don't have the reactive web client, but if I added the reactive web client type, I could use that to call other services. I could do all sorts of interesting things here, and those be non-blocking, right? And that's very valuable here. So in this case, it's fine. Let's go ahead and just leave it as is. When the request comes in, we're going to take the incoming request, uppercase it, and then send it out as a reactive stream outward. And that's going to be all, inputs and outputs are still going to be managed by Kafka, but now we can have this nice programming model, which integrates with other things that we want to talk to in terms of these reactive types. All right. So uppercase Maven clean package. All right. And I'm going to say riff create Java. I is input, remember, so uppercase. Name, again, minus n is name, shortcut for that, is uppercase because why not? O is the reverse, is the Kafka topic that we want to forward the response to, and in this case we're going to forward it onto our reverse, so it'll have the effect of chaining these two different things written in different languages. And by the way, this is one of the really interesting possibilities, as with PAS, as with FAS. You get the ability to mix and match the best of breed technologies for the job at hand. Obviously, these are fairly lightweight, trivial examples, but maybe you want to use something that's written in shell, right? Or invoke something that's written or more readily accessible inside of a shell script. Well, I think some of the ugliest code I've ever seen has to do with the integration of Java and native code, as you might, for example, with JNI, or Java and operating system command line utilities, shell scripting, shelling out to a command on the operating system. That kind of code is tedious. It's hard to guarantee that it works. It's just something I like to keep isolated. And if you've ever used, for example, the ImageMagick Java binding, you know that some of this stuff sometimes leaks, right? So it's just really nice to have this opportunity, this option to say, okay, this is, for example, a command. It is off by itself. I'm going to start it up, do some processing, and then kill the container and claim all that memory. There's no possibility of a leak in my Java application, right? In this case, I can. In this case, it's just a Node.js example, so really nothing gained. But imagine, for example, that ImageMagick scenario. Imagine you wanted to have something that did something with Java in Java, and then forwarded the response off to ImageMagick to do some actual image resizing. Well, you can use the API itself. You can use FFmpeg. You can use all these command line utilities that are much more readily manipulated on the command line than they are through some third-party JNI binding, for example. Okay, so riff create Java -i uppercase, n is uppercase, out is reverse. We're forwarding it onto our Node.js handler. The artifact that we want to use to run this is uppercase snapshot jar. So before I used -- file path, and I said just figure it out by looking at the current directory. Here I'm being very specific. There's a lot of things in the current directory just because of the nature of a multi-directory file system and structure for a Java application. And then finally, I'm going to tell it what to run. So I'm going to say, I want you to run this function called uppercase inside of this class. I'm going to give it 2 bits of information here. Uppercase, that's the function itself, and the main class is this, right? Now, it is my hope that the Java function invoker gets to the point where I can say, okay, I don't need to specify the handler. Here's the jar. It's a Spring Boot app. Just figure out the bean that has that implements function, or better yet, just here. Here's the name of the function to look for. But for now, this is not a big deal. All right, you can see our function and our uppercase have both been deployed, and our reverse and our uppercase have both been deployed, and we can interrogate the runtime and ask it what functions we've got available to us now. So those are both there. And what I want to do is I want to send a request to the uppercase. Hello, beautiful Riff, and that's the minus D is the data, right? Just like in the curl command. And by the way, if you were doing something more complicated and you wanted to, for example, send JSON stanzas, you could do that. You could actually say application, content type equals application JSON, and then in this case, the flux of string could be a flux of, whatever. It could be input private string value, and then you could have a flux of inputs, and then make sure you have getters and setters. It's Jackson marshalling, of course, but that would work as well, as long as you specify the content type. It'll do marshalling with the strings. So by default, the runtime itself knows about strings that get moved around, but there's no reason you couldn't turn these things into more interesting types based on your language's support for marshalling and so on. Okay, so what we're going to say, publish this to the uppercase Kafka topic, sending this message. We don't need to specify the content type, it's just implied. And that's it. And we want to specify a reply. Now, remember, I've chained this to talk to reverse. So we should see it take our lowercase hello beautiful Riff, uppercase it, and reverse it. Okay, container creating, running. There's the reverse. It's now running as well. And there we go. Hello beautiful Riff. All right, so that worked. That's a very simple example of two functions chained together in this way. And you can do all sorts of interesting things here. I mean, I gave you some examples, but let's talk about a more typical scenario, something that is sort of long running. I mentioned the image magic thing because I'm sure we've all had code in our system somewhere that has to shell out, and that's a common enough thing. But even in Java, we have things that we would prefer to have done outside of the traditional request response path of our application, and for some things for which we can be sure it will eventually succeed, we can use, for example, at async, and that's certainly one option, but that assumes that the runtime will always be there, that the application will never lose any state. So I tend to shy away from that, useful though that is. I try and keep things staged through queues, right? The staged event-driven architecture, very, very simple. So, and the reason I do that is because if I should lose, if my client, the thing that's creating the work, should fail, then I can at least restart the client and it'll reprocess any missed messages. We have that built in now. This comes for free. That guarantee of the stage event-driven architecture approach, that's already here. It's just there for free out of the box. So let's go ahead and build a Spring Boot application that sends email. And what we're going to do is we're going to send email using SendGrid. Now, SendGrid is a email as a service sort of runtime. It's a SaaS offering that has an API, and it needs an API key. So what we're going to do is we're going to use the SendGrid API to authenticate, and we'll use the client Java binding to create the right payload to then send that request, and so on. In order for this to work, though, we need an environment variable. Okay, so we need somewhere to stash the authentication API key. So let's go ahead and close this and create a new function, and this one will be called mailer. All right, mailer. So I don't know that we need all that much from this. I guess we could use Lombok, but actually we don't even need that really. So this is just a very simple Spring Boot app. We'll hit generate, and that'll give us this mailer.zip, which we're going to open up in our application and our IDE. And now, before we can, what we need to do is we need to add the normal stuff that we just did before, the dependencies, first of all. Alrighty. Dependencies, dependency, and Spring Cloud function dependencies. Type is equal to POM, scope import. Alright, so there's that, and we need the Spring Cloud function starter function web, and voila. Okay, so those are our dependencies. Now, we also need the SendGrid API. We need the SendGrid client on the class path here, so let's go ahead and add a dependency for that. Okay. The SendGrid dependency lives at what is it? It's SendGrid Java, right? Yes, I think so. And 4.21.1, and voila. Okay, so that's there. Now, in our mailer code, we're going to create a simple function that sends to our we'll just send it to ourselves. Basically, we're going to send an email to ourselves. In order to do that, we need the SendGrid client. So we're going to say @bean SendGrid API. That's the interface. We might as well SendGrid, and we can just call this SendGrid. And in order for this to work, we'll need this environment variable. I happen to have this environment variable on my local machine, so any tests I run will work. But this isn't going to work without that environment variable in the cluster, in the Kubernetes cluster. So we need to actually set that up, and we'll talk about secrets management here in Kubernetes in just a second. So I'm going to say return new SendGrid. Whoops, I need the actual implementation, the concrete one. Passing in the key. Alrighty, good, got that. And we'll create a function that takes in a string, which is the email, and it'll return a Boolean sent, right? So imagine you have something that, somebody signs up for an account or something like that, and you want to do a confirmation email or whatever. This is one of those things where it might take a little longer than you are prepared to wait. You might want to format stuff. You might need to prepare images, whatever. This could be the kind of stuff that you run as a cron job. It might be a report that runs or whatever. And this is a perfect example of the kind of work that I would be very happy to throw into a function as a service platform. We used to talk about tuple spaces. The idea of a cluster of workers that could then just aggressively consume. These are the greedy consumers. They would aggressively work still. They take work off of a queue and process the work and then disappear, right? And this is the kind of stuff that we want to we can support very naturally using a function as a service runtime. So here we are, new function, and in our function we're going to take the email and we're going to confirm that it was sent. And in order to send, we need to use the SendGrid client. Okay, so let's see. I don't know if we even need that. Probably not. Email. Hello. All right. Now let's see if I can remember this API. Email is from new email spring-tips@joshlong.com. All right, that's not a real email address. Would that it would be? I should actually probably create it. Subject will be beautiful riff. All right. Email to will be the email that we get as a parameter, wouldn't it? So there we go. The content, let's see about this, equals, I think it's just text plain, if memory serves, and it'll be hello beautiful function as a service, or you know what, just go for the traditional hello world since that's super appropriate. Mail is the helper object that it comes from the SendGrid API because what we're doing is we're using the SendGrid API to post to the REST API. So really we've just got some fancy composite types that we can use to make short work of marshalling back and forth to their API. So to, and then content, and voila. Okay, and now it comes to the actual interactions with our SendGrid client. So what we're saying is request. Whoa. r equals new request, and passing in, we say r dot set method equals post, r dot set body, that'll be mail dot build. All right, put that back here, throw new runtime exception, bubble that up to the client. What else do we want? We want r dot endpoint mail send, and I think that's it. I think that's those are the critical lines that we need. All right, now we need to actually do it. So let's get the response. We'll say send grid API dot what is it, API? Yep, r. That'll give us back a response, and then using the response, we want to confirm that it was sent. Response dot get status code should equal HTTP status dot OK dot value. Return sent. Okay, there we are. So there's our simple function, and that should do it. That's a very simple example. Obviously, you would have HTML and formatting, and I'm sure you'd have a designer in there somewhere, and all sorts of stuff. Okay, we have just a very simple example. Now, this is a function. It's going to be called mail, and in order for it to do its work, as you know, we need this environment variable, this key here. Normally, in fact, I could go a step further. I could say, send grid dot API key, and then spring.sendgrid.api key. This will actually auto-configure a SendGrid object for me. This is a Spring Boot auto configuration. So I could say spring.sendgrid.api key equals this here, right? So there we are. That would be the environment variable, and this will give me a SendGrid object. SendGrid. See, so it'll create the HTTP. It'll create this SendGrid API key just like I did. So we could use that. That's actually probably even cleaner. So let's do that. Actually, we'll just let Spring Boot do the work for us. All right. Now we've got the application. We've got the SendGrid implementation. I think that's it. We need to now deploy this application, and in order for us to do that, we need to tell Kubernetes about that API key. So this is where it gets a little tedious. We need to actually dive into Kubernetes Secrets. Let's see. So here I have this value running on my local machine. I'll say echo SendGrid API key, and I want to write this out to an API key.txt file. I've got the environment variable on my local machine. I want that to be on the local file system. You'll forgive me if I don't cat that environment variable there. I'm going to say kubectl create secret generic SendGrid API key, and I'm going to say I want it to come from a file, and notice that there's two things happening here. I'm saying create a secret called SendGrid API key, and then that SendGrid secret can have a dictionary of values, of keys and values, believe it or not. So the key, it's not just a key and then a value, it's actually a key that then gives you access to a dictionary. And so here I'm saying, again, SendGrid API key. Now this is, if you're doing a username and password, you'd have SendGrid API key from file equals username equals and then the value from the file, and then dash dash from file password equals and then the equals password and then equals the file from the password file, right? So I'm going to say SendGrid API key equals dot API key.txt, right? So kubectl create secret generic SendGrid API key from file SendGrid -API key dot API key.txt. All right. Now if I look at that, I say kubectl get secrets. All right, and I can say kubectl get secret SendGrid API key YAML. So I'm actually, and I don't need to do this, but this is kind of interesting. you can see that this is this invocation, this dash o YAML tells Kubernetes to write the definition of that resource out into a config file, into the YAML stanzas that I would need to then, if I wanted to version control this, I could actually version control it like this, and then use the kubectl, create secret, and then tell it just use this file instead of me doing it manually on the command line. So there's that. And now what I want to do is I need to create that function. I need to create that function first, and I'm gonna have to create it and then run it. Basically, I could do this in other ways, but just to be consistent, I'm just gonna say create the function. -I mailer, -n is mailer. That's the name. -a is, let me do a Maven clean package first. I just realized mailer, Maven clean package. I'm gonna create the function first, and it's gonna fail, but I don't care. And then I'm going to update the config file for the resources, for the function resource that we are given when we create the function. So I'll say riff create java -i mailer, n mailer, a target mailer. Handler will be mail, and main will be equal to com example.mailer dot, is it mailer application? Yeah, that is. Let's just copy that reference just to be darn sure. Okay. So that's the riff create java -im. Okay. Create that, and you can see I've got these new resources now. And as before, I'm going to open up this function config here, and this time I'm going to change it to reflect our new secret. So we're going to go to container, and we'll say env, and we'll say dash name will be send grid API key value from, and here we're going to use a secret key reference. So secret key ref name, and this is where the dictionary comes in. So the key in that little dictionary, if you will, is SendGrid API key. The key that we want is SendGrid API key. All right. And then that's it. That's everything we need. And with that in place, that should create an environment variable in our container, in the function container, and make that available to the Java application, which will then boot up with this in place. So now we're going to say riff update. Right. All right. So good. So there we go. There's our application. Let's now try it out. Okay. So I've got this. This is my inbox here for josh@joshlong.com. I'm looking for Beautiful Riff as the subject here. Right. That's what this is right here. So let's go ahead and now create some traffic, or create some requests. Where's our? Here we are. Okay, I'm going to say riff publish -i mailer -d is josh@joshlong.com -r. So we're going to send a request to mailer, publish it there, and it should, if we've deployed everything correctly, result in a email arriving in my inbox in just a second or so. Creating the container, up and running. It failed. What did I do wrong? So, kale -d mailer. Kale's a nice command line utility to debug this kind of stuff. Did it work? Looks like it worked. What happened there? Clearly it got the message. Did I do something wrong with the code? Oh, very curious. So it ran, and I got a false. That's log factory.getlog.info print stack trace. Although it would seem that that should be there anyway, so you know what? I'm going to go ahead and try and control how this thing gets created. That was working. Send grid API key. Bean send grid API at value string key turn new send grid API key. All right. Looks like it should be the same though. So we'll say email from subject email to. Email to is here. Email from content is text plain hello world. Is it not from subject to content? Yeah. Request method mail send mail.build. Good. API.request. Okay. Hello. Functional world. Hi to, I wonder if it's some sort of spam filter. Hi to the functional world. All right, hello. And optionally, okay, Maven clean package and Riff update. Eval docker minikube docker env. All right. Oh wait, I did get those. It sent false 819 and there's another 822. Oh, so I did get them. Why is it returning false? That's interesting. I got some other code, but nonetheless the emails did arrive. I just didn't refresh the email console there. So that's silly. I some sort of issue there with the if status code. What is the issue with the status code? Response.get status code equals http.ok.value. It's false, and yet it's working there. So hello to the functional world. All right, so that does work. So you can see my point. There's opportunities there. You should definitely understand SendGrid before you run this example. So clearly, I need to do better there, but that does work. The result is that we can send emails with the invocation of a single request. Now, taking a moment here just to focus on what's happening, you can see that I'm sending a Riff publish, and that's actually posting to the HTTP gateway inside of it's the there's actually a incantation that you can use to get the HTTP gateway for Project Riff, and that incantation, I think they're even kind enough to put it here on the blog. When you I think when you do this Helm chart, it'll actually show you the environment variables you need to be able to arrive at that same URL. So the secret to get those URLs. And I'm sure you'd have that figured out at some point. So you can actually just post. You don't have to use Riff publish. You can just make an HTTP post to HTTP, your gateway IP and port /request / and then the name of the function, and you'll get the response back. All right, my friends. With that, we've looked ever so briefly at a number of different aspects of functions as a service with Project Riff, the new open source Apache 2 licensed function as a service runtime from Pivotal, and Spring Cloud Function, the easiest way to build functions that work in a number of different function as a service platforms, regardless of the destination, using Spring and taking advantage of all the sort of things that you might expect to be able to use from a Spring Boot application, including properties and so on. And we also looked at Kubernetes Secrets as a way of, how do you tell your application about these different properties, right, that you need. So you can do that using Kubernetes Secrets, config maps, or you can actually just hard code them in the function resource there, right? Don't put the passwords there. Definitely don't put that there. But configuration values themselves that need to change in production versus, for example, development. You could have the defaults in your development environment and then put the non-secret, secure stuff just directly in the function resource. All right, my friends. I hope you got something out of this. And as usual, thanks for watching, and we'll see you next time.